right, I see several familiar faces. I see lots of new faces as well. My name's Dave Burnison. I'm a senior DevOps advocate here with GitHub. So I talk to a lot of our large enterprise customers all the time about, mainly about DevOps and that, but of course these days a lot about AI. But I just want to welcome you today to our GitHub office. A couple of things here to about, we love to share the space with you, but we just ask that everybody respects the space, you know, keep it clean when you're done with your pizza and that. We've got garbage cans back there and over here and things like that. If you need something, you know, reach out to me, or we've got or the community managers, or we've got Sarah and Tony out there from GitHub as well. If you see something questionable, please let us know. We would love to invite people in and have you here and everything. And we don't want, something to happen that's going to say, maybe we can't do this again in the future. So if you see something, please say something. So what I typically do is I'll highlight, recent GitHub Copilot, GitHub AI announcements and stuff. I always have the resources here. I will post a PDF of this in the Slack channel after I'm done here. So that'll probably be there before everything's done tonight. But yes, feel free to take a picture because there's all the URLs and everything there as well. You can keep up with the latest news on GitHub Copilot and all of our AI announcements by going to our blog, specifically things that are tagged with Copilot and such. We also have our change log there, which is our release notes. So we may put out little incremental features, may not make a big blog post about it or that, but it might be something very important to you depending on how you're using Copilot already. So follow the change log as well. And then the third one is we have an area of the blog dedicated to AI and ML as well. I'm not sure if we had any recent posts under that category. We probably did from GitHub Universe. So speaking of Universe, at this time last week, I was in San Francisco with about 3,300 of my closest friends at GitHub Universe. That's our big conference for the year. And we had, if you go to githubuniverse.com, we've got over 50 recorded sessions there, the keynotes and everything, but also, take a picture of this. I should have made bigger font, I see. But again, I'll post this as a PDF where you can see the blog posts that talked about all of our news and everything. I'm going to highlight just a few things here. Again, lots of details in the change log, and you can see all the sessions on demand. The thing about going to githubuniverse.com, all the sessions are available on YouTube. But if you go to githubuniverse.com and say, show me the on-demand sessions, you can say, oh, I just want to see the AI sessions, or I just want to see the security sessions or whatever. So you can filter it down very easily and quickly to specific sessions and stuff. So we had a lot of announcements. Some of the biggest ones, I don't know if you've heard about GitHub Copilot Workspace, but Workspace allows you to start with a block of text, say in an issue, that talks about, hey, I want to add this enhancement to my application, my solution, and it'll help you build out a plan even before you start writing code and everything. So we're bringing AI to yet another level of software development, even before the actual writing of the code and everything, and see all the way through writing the code, debugging the code, creating the pull request to merge into your main branch and all of that. So a lot more for Copilot, or a lot more AI being applied to the software development process. Copilot extensions. We've had tools like JFrog and Azure and Jira and Sentry. I think there's already 20 or more extensions in the marketplace. So while you're working in Copilot chat, you can say, hey, what was the latest issue assigned to me in Jira? You can stay in the flow, just stay in your developer tools. You don't have to be bouncing between Jira and JFrog and all of that. Just do it all right from within Copilot. GitHub models. So a couple of months ago, I gave a little presentation on GitHub models. The key thing that has changed since then is, let me zoom this in just a little more. So when I go in here, I can go into the marketplace. So this is github.com/marketplace. I can go into models, and you can see we've got quite a list of models that you can play around with, whether it's ChatGPT, Llama, Mistral. I don't even know all of these models and things. But as an example, I can go in here and pick a model, and I can go into a playground for the model. So I can start, putting prompts in there. I can play around with, what are the different settings to feed into this model. The new thing now is I can compare two models side by side. So I'll pick Mistral and Llama. And when I put a prompt in, write a limerick about an AI enthusiast user group that loves to eat pizza when they meet. And then you can see the results side by side in the two models. So if you're looking at adding AI into your applications, you can actually play around with the different models and compare the results and everything. And then begin to, where is it at? Let me get out of the compare mode. Yeah, I can go from, ooh, I'm drawing a blank here. I can go, I can go in and start playing around with what would code look like for this. So how would I use this in a Python application or a Java application? I can pull it into what we call a code space, which is essentially Visual Studio Code running in the browser, and actually play around with it even more and more. So I think that's one of the exciting things for this group. All right, I'm going to leave it at that. There were several big announcements and stuff, as you can see from, another one. For those of you that are working with Xcode, now we have code generation for Xcode and things like that. So definitely go to GitHub Universe, check out those announcements and things. There's a lot there for you. And enjoy tonight's event.
Thanks, Dave. Yeah, that can go on like probably a couple of hours. Maybe you can ask him about how you can unpack that JSON as well. Dave is a really nice guy, so reach out to him. He answers like usually 3 to 5 minutes. I'm kidding. Probably 24 hours or something like that. Okay, so let's get started to main event. We're gonna have our first speaker, Chenghao. Yep. US setup. Yeah. So she's from Goodrx, she's going to have a talk about the rack models.
Thank you. Hey everyone, give me a second while I connecting to the Chrome. Okay. Test. Hey, hey everyone, I'm Chenghao, and my talk today is basically about RAGs from personalized ML AI in healthcare. Just sharing the learnings and the visions currently right now that is trending right now in Goodrx. And before I jump into the technical part, let me introduce my company. So Goodrx, we are actually a healthcare platform focused on making prescription drugs affordable. So basically, the company connect with consumers, healthcare providers, and pharmacies through the platform, and just to reduce the cost in the US healthcare system. Our product focus is to offer cost-saving tools for prescription drugs, telehealth service, and subscription programs, and basically to do the to find the best buffer of the prescription between the potential discounts and pharmacies. Actually, we do a lot of stuff and have a great vision in the AI, which is actually to leverage the AI to enhance access to basically to access to affordable healthcare and streamline prescription management, and basically also improving internal like efficiency of our developers and employees, the productivity. That is very, very abstract on high level. And now jumping into the major challenges right now we're facing, which is probably what you guys are more interested in right now. So all the challenges right now, we are focused right now in AI healthcare is some key responsibilities that Goodrx and the other, basically all like companies in the industry trying to resolve right now. So it's very important to understand that like AI supports and basically machine learning models are still have to be very slow and very cautious to be applied and used in productions in some very serious industries such as legal and healthcare. And the major reason and the major challenges is one of them is the data privacy, because healthcare data is highly sensitive and requiring the measurement of privacy and compliance with so many regulations from different aspects. So it makes the data handling more challenging compared to, other industries and areas which more like entertainment and more like less serious, for example, like Instagrams, like social networking and like purchasing stuff like in retails, right? Another stuff is the trust and the ethical challenges. All the AIs that solutions we are right now trying to build up in healthcare is facing actually a higher like issues in this case, considered to ethical considerations, including some bias or some false positive stuff in the AI models right now we're using, and the impact which on the patients or even the customers that is using the pharmacy drugs and prescriptions, right? So gaining trust is very important, and other industries don't really have to consider too much about the whole process unless something really giant happen and having a security and blaming process in this case, right? Another stuff is regulatory batteries, because healthcare actually has very strict regulations, and actually it is the major thing that slow down the adoption of AI solutions. The approval process for AI solutions and for AI tools is actually longer compared to like other solutions and other like products in the industry, right? So based on all of these high-level challenges, what we can do actually in the industry in a more adaptable way is having multiple different directions that actually we try really hard and see the importance of us. And here are 4 of them. One of them is the efficient data processing, the amounts of the patient data, and because we need AI to do the work to help the process and make that efficient. And also the second one is personalized care. supports the personalized treatment, and the recommendation is very important to us. So it enhances the patient outcomes. And I give some examples like LTP and saving program, which I'll definitely reach to in the later slides. Another one is cost reduction. It actually addresses inefficiency in the healthcare supply chain, which is actually the major core stuff right now. Goodrx is building on top of it, and thus it just leads to cost saving. And the last one is telehealth and the chat box. It definitely provides the telehealth treatment and consultings, and also the chat box, conversation and communications, which becomes very important to us right now, probably starting from the quarantine, but now it just becomes part of our life. So, which is also very important to like customer service. And all of these 4 different directions and the importance will have totally different solutions. And I'll explain why. There isn't a centralized and a single solution for all of them. And the first one actually that is very popular and we try out in Goodrx is rag and prompt. So basically, rag, why we do that? Because rag is like rated Q1 #1 in 2014. And it is recommended to adopt it. So we try different ideas using rags and projects throughout our different departments and teams, including multiple different in parallel A/B testing and war rooms. And one of them that is actually tends to be worked really well is using the drug histories and doing that as a context for the rag model. And the prompts currently right now that work the best is the data retrieval from the backend with synthesized result from the articles, which is provided by majorly from Goodrx providers and article writers. Also, like, could be easily extended to public writers and the resources after they got like reviewed and approved, able to use for our purpose, right? And what we actually use in the rag and prompts is OpenAI. Yeah, we choose OpenAI over Gemini and MetaLlama, and use the AI embeddings, which includes 10K articles into 2 GB vector stores. I know is not too large, but that is everything we get ever beginning with approval. And do the training set for each test outcomes and each test experiment. And this is the high level like architectures. I wish it could be zoom ins, but if you look at our own workflows, and this is the major designs in this way is we want to making sure the response and the result in different platform after the rag and prompt has been applied could be fitting in our users' need. The vector stores, which is we use the in-memory storage, and then we use the OpenAI articles and embeddings, also including contentful health-related articles. And in this case, we provide the response of the prompt into different platform, which include, which this could be readable from the last row of the people is notifications, basically chat conversation, and the web and mobile. All right, so what makes the rag very accurate in this case is the cleanup, the validations of the data with the claim history. On the left, for example, it is metformins and other like different drugs and the prescriptions for each user that we line up on like person IDs and the common IDs for all the data who have been cleaned up and the structure. That makes the prompts actually will be accurate for each of the persons, like that using, for example, the chatbot, and providing more like useful informations rather than like rely on the user to providing the context of providing the informations. And another one is, besides the regular like telehealth and the chatbots, yeah. Oh, can you?
Hello?
Yeah, thank you for the mic. Can you repeat the question?
So I was just wondering, what was your chunking strategy for taking the health information from the health documents and patient data into the vector database? I couldn't, sorry, I can't really see the graph in the back.
Oh, no problem. So basically, the question is how we do the chunking for the customer's claim history. Is that right? Yeah. So that is a good question. How we really do it in a scalable way is actually user have. There are so many different phrases. User have like claim history and the prescription history, and also behavior data. Like for example, if they click or search something, right? That is always gonna to be like batching down to each claims. Like if you search something and then you find a discount and then you do make a claims. In the past, that all of the data will be one of the pieces and drop down to one single records for that user, right? And when we do validations, it is the validations of that user specifically data, how whether that is qualifies to do the trainings specifically for example, this model like web browser, like answer questions or recommendations on the pricing page, right? So that is the first level. The second level is when we do the vectoring and the in-memories, is this records going to be allowed to use, for example, specifically for this use cases, right? That is another checkings, and when you do the chunkings and the bucketings in the storage levels, and whether we want to do indexing, right? In this case, to making that this data is more structured and sorted in a more efficient way, right? So definitely there's multiple different layers, which actually I can share more details like how this is going to be worked in my next example of the different workflow. Wish that answered questions. And yeah, without further ado, personalization with LTV. So basically, this is the very next directions that Goodrx actually heavily try out. Is part of the personalized care. And one of the great, very impactful recommendations that we tried out is actually lifetime values models, which is short for LTV personalization. And why we don't do RAGs in this case? Because, yeah, which is reflect to the questions like about the claim history and the user data. Not everyone has enough history data for us to do training. And there's also so many like other qualified behaviors data for RAGs to do the training and to do the prediction. So LTV in this case is to resolve this, the problems like where users doesn't have pretty much high, like LTV scores, which recently they don't have enough behaviors, but it doesn't necessarily means we cannot be able to do the prediction, right? So by using the LTV to predict prescription, it is how it works. Let me share some index. So in the LTV models, linear regression is to use to identify the relationships like between a customer's claims and a claims behavior and their future like prescription behavior in this case. And the training stage is actually using the ML models that is using existing claimers, and we have the index and we have the LTV models do the prediction, and we use it to do we drop down to the common IDs levels, and we do the prediction on the person IDs given a recent claim for the claimer. So that is why it is being used for the scoring stage with the prospective users that it has home views or house or page depressions. Then we do a prediction of different scores and the values in this case, right? So it makes sense to, by this model, it is a good way to do personalization and the recommendations for users. So right now, this is being used in incentive market and point of sales, so which is short for POS. So you can see all the huge data models right now. It is being get from different resources and the different priorities with, for example, Facebook and other meta social networkings, which have the potential users that it is highly likely to get a high LTV scores, and then most likely to have a potential offer that we can build up in this case, right? So it could target the social ads and turn the high LTV users, and we call it like Facebook lookalike audience, and provide them like better than usual like discounts, which is up to $20, and it could be reused discounts on multiple different medications in this case. Yeah, I know it's a little bit small, but you can see the combinations and the different ratings of the priorities is actually capsuled inside of the whole like workflows with personalization and point of sales. And I'll give an example of how it looks like in real life after all those prediction and of the models have been applied. So on the left, you can see this like LTV discount generated and applied on the website, which is causing the final price to be $4.18. Well, if the users doesn't have a like LTV discount offer, you will fall back to a regular like models that is trained to have a less discount in this case, which is $24.18. Oh yeah, so that is like a real like examples like you can see on the website right now. So we do have the models in real time, and also we have fallback. And another wholly different direction of projects that provide recommendations is we call the saving program. That is discount recommendations based on saving models, but with like heuristic post-trainings. You can imagine it's like, yeah, we do have RAGs and LLM models, but we cannot directly use them. And the heuristic workflow is very important, and it's based on the vectors on drugs, pharmacies, and quantities. And I think that is the major part, like how we can not only guarantee the discounts and the values we can provide to attract enough customer, but also at the same time, the recommendations is under controls and we don't have actual issues about the worrying about the recommend result. So here is the one of the screenshots, like how we actually do heuristic models with a glance. With the integrated with the saving program, it has been like a do the prediction and the post training and fine tuned by multiple different factors, which we chunk them into different groups. And you can see like in total is 8 groups. And the way it works in our own workflow is to supervise and reinforce the learning with the adjust feedbacks, right? So that is how we control the saving program. And the major objective is definitely the maximum revenue per price. So by partner, drug, retail, we use the historic patterns and the bucketing into groups and recommend best discount in this case. And this is the full high-level workflow of all the aforementioned sections, like combined together to have saving programs working from end to end. We do use the database and do the storage from our point of sales and provide that into our own like workflows. And you can see we have decision trees to see whether we want them to be launched and then move forward to next stage. If not, actually, they won't be activated. And they got refreshed every day. And so what is the major key takeaways? Major takeaways is actually the major challenges is in healthcare is data privacy, and one of the solution we figure out is to build our own workflow to control the result of the recommendations and to control the response of the predictions, right? That's why we have so many different solutions, right? And there isn't a single best model for all projects and workflows. Some of them, the reason why we try different ways for different programs is some of them, they cannot be applied from one to another directly. And if the result is not good enough, we cannot launch it, right? And the way how we're going to evaluate and match the right model to the right project is the key. And how to do that is actually based on the quality, cost, revenue, and all these via A/B testing, usability test, short-term war room, or just hackathon. And as soon as they got the outcome, it is good. It is more likely to get approval and moving the process to the production, right? So that is all I gonna to share for today as the time running out. And if you're interested, download the app. And by the way, we are hiring. So if you think you're a good fit or even interested in healthcare, interested in AI, I'd love to talk to you guys. And yeah, feel free to ask any questions you have.
Anybody have a question? Okay. Good.
Hi, I'm Pierre. I have a few questions. So, first one is how do you make money? And then second one is
Sorry, what is the first question?
how are you making money? First question. And second one is how is it helping the customer save money? Let's say if they already have insurance, right? Is this for people who without insurance? And then the third question is, how are you helping the partner, let's say like Walgreens or Rite Aid? How are they making money? How do you make money, and how customer is saving money?
Yeah, that's all very good questions. And first one, like how are we making money? Yeah, business strategy. How can I tell you? But like from a customer, I have like I need a job hat right now. So customer wise, I think we can currently right now, Goodrx is providing pretty good programs for different kind of use cases of the customers. And it actually reflects your second questions is for customer who already have insurance, like or co-pays. They're also specifically like as the saving programs, as I say, even with the co-pay and the insurance, we have pretty good saving programs that based on our great heuristic models and heuristic steps, we can provide a discount that make your final price even lower. And that is thank you for the thanks to the technology that is always guaranteed. So for users with insurance or co-pays, actually Google can have discount that is can even be that. And for users who are like have a, for example, like long-term usage planning that might be run out of the insurance at some point, or even for the users that they don't have insurance, but they definitely need some medication and prescriptions for either for themselves or they have for their kids and families, right? We have different like kinds of discount programs, and for us, it's making money by using subscriptions, which is the major key income and revenues that is lying on. But even for free users, discount is still like available for most of the most of the cases. But like with subscription, you probably even have extra discount you can see in this case. If you have, for example, some disease and some claimers, we observe like they have to take some medications for like multiple years. So if you think of in the long term, we want to support in this case like providing more affordable price. I think that is the major key strategies for this company. And for your last questions, like how pharmacies and the partners works, I probably not the best one to answer. I know like we have people coming from today from Walgreens. Maybe they should be able to provide their sales on their side, right? Otherwise, it could be like me like bragging about how well we collaborate with them, right?
Okay, so let's take maybe a couple more questions. Any other?
Got one back here.
So I guess I just need a bit of clarification. What is LTV? Is it lifetime user value? And do you decide discount based on LTV? So if the LTV is low, then you don't offer discount. And if LTV is high, you try to offer bigger discount.
I wasn't, the sounds coming to me is actually pretty low. Can you repeat?
So question about one of your slides. Can you comment on what does LTV stand for? Is it lifetime user value?
Oh yeah.
And like,
definitely.
how is it connected to providing discount to the user? So if like LTV is high, then you give bigger discount and try to retain this user on the site?
Oh yeah, definitely. That is a very good question. So basically, think about if you have like users that have claim histories, but not enough. Instead of using RAGs or pretty fancy LLM models, very likely these users may have a pretty high or low like LTV scores in this kind. In this case, it's lifetime values that is like indicating this user might not really interested at the moment, but based on the context we have, it is more likely they will come back at some point, right? So that is kind of like models to do actually linear regression in this case to provide a discount for the users. for examples, like you have some claims, but at this point, you might not need any more. But based on your LTV scores, we predict, for example, like next week or at some point, you're probably going to think about it and, oh, like you need to check the discount on this drugs or on this medications combinations or any, like some drugs you need in that case, right? So that is something like we can predict in this case. That is not only based on the fancy RAG model, but also based on your lifetime values. Does it answer your question?
Yeah.
I have a follow-up question regarding the lifetime value and the discounts. So based on the models and based on the previous discounts that you had, you have a model that says, okay, if they come and don't purchase, they have a low lifetime value, I'm not going to give them this discount, right? But
yeah,
this is kind of a loop, right? So how did you come up with that? Like, did you at some point offer really low values and see that, okay, it does not change the customer's behavior? Or is this just a decision that the business made and said, okay, like if they've came back, like let's say so many times, then I'm going to give them the discount to keep them, but I'm not going to try really hard to retain new customers?
Oh yeah, that's a very good question, and actually that is the question we met in during the projects while we're launching, right? So the key, like the motivation behind that is it is questions in general, like how we do predictions like iteratively instead of looping, right? So actually the rating and analysis, it is very important in this case. So you're asking like how we do analyze and how we do the analyze and evaluations, like based on the existing like a prediction for like prediction force and the prediction values, right? So actually right now what we are doing is based on the user's data, and we always have different versions of the models of evaluations. So new version of the models is going to do the evaluations, and the older versions of the models of LTV models is going to do the prediction. And we can do like fine tuning and the evaluation in this case using BI, like using analysis tools, which pretty general, like for analysis and guardrails and the analysis based on the result, like as you can see, this is a daily running jobs, right? So based on the previous day data and based on history data, like we can do like different kind of like adjustments. So it will make sure, like guarantee, like we have like non-looping and we have like accurate and appropriate recommendations in the saving program.
Thank you. I think at Chenghao, you're going to be around after the talk as well.
Oh yes,
Yeah.
definitely.
So
I'll
if
be
you guys have
around
any-
after this.
Yeah. If you guys have any question, please come and talk to her.
Definitely, I feel the enthusiasm, and thank you for all the questions.
All right. At this time, we're going to bring out the second speaker, Jeff. He's from Gekko, and I guess he's going to talk about the different components around the AI lifecycle. Excellent. While he's setting up, just a community, not announcement, but yeah, we have a water fountain in the back, so stay hydrated. It gets a little hot, after. So yeah.
Hi, everyone. I want to introduce you to Bob Smith. Now, Bob is the VP of IT Operations, Business Analytics, and Security. He's got a lot of challenges on his plate. He's got frequent downtime with his website. And his marketing and executives are really frustrated because they need to get IT involved in order to get the data out of their analytics tools such as Splunk, SQL, and Oracle. And finally, the other challenge is the revenues have been increasing, but the profits been going down. So the direction from his CEO is to reduce the overall costs and increase productivity. So the initiatives he has on his plate are the marketing teams and executives want a chat-like GPT interface in order to get the data out of their business analytic tools rather than relying on IT to get the data out. He needs to have 5 nines in terms of uptime. That means he needs to reduce the downtime to 25 seconds and then reduce his headcount by 15% and increase productivity by 25%. He's got a lot on his plate. Is this similar to the challenges are you guys facing out there? Okay. All right. Hi, everyone. My name is Jeff Kent. I'm with Gekko Corporation. We are a Splunk, IBM, Silver partner focusing on AI, IT operations, business analytics, and security since 2014. How many of you have worked with Splunk at all? Familiar with Splunk? Excellent. Now, Splunk is excellent, so cool, because people really enjoy the process because you can index structured and unstructured data. And then once the data is indexed, you can just search on it like a Google search and find the information that you're looking for. Now, we started working with Costco. They had a problem with their website, and they couldn't find an error, a 404 error on the website. It would come up just sporadically, and they're very frustrated because they couldn't find this error. So what we did is we indexed all the logs that are associated with Costco.com site. And once we indexed all the logs, we did a Splunk search using the SPL code, and boom, immediately found the error. And Costco right now is using Splunk to do their business analytics, IT operations, and security, and they're doing about roughly 3 terabytes per day indexing this information. So you're thinking, well, this is an AI talk. Why are we talking about Splunk? It's because AI is the next future at Splunk. Splunk was very popular when it came out 15 years ago. It is the #1 tool out there for SIM. It's used in all the Fortune 500 companies out there. But the challenge is, I think a lot of the tools out there, you need to have code in order to get the data out. So with AI, it's very similar to Splunk, where you can index structured, unstructured data. But it's an enhancement to Splunk because you can do video, images, audio. And unlike Splunk, you don't need any code to get it out. You can use NPL or natural language, or what we call code-free analytics. So how do you get started with AI? Well, first of all, you got to choose the correct LLM. You have to look at the overall costs. As you scale your product up, how much is it going to cost you? As you look at the different models, do you have the data that is going to give you the answers that you're looking for? Performance, customers right now need the answer right away. They don't want to wait for the model to spin up and give you the answer back. GPU requirements, do you need thousands of GPUs to run your model? Or can this thing run on a smaller platform or a PC? And then what is the content? Does the content in that model have toxic content in it? Does it have copyright content in there? And then finally, what platforms are you going to be running this thing on? On the cloud, on-prem, or what's really popular right now is hybrid models. So when people start their AI initiative, a lot of people think, let's use OpenAI. It is the best tool out there. It's the first one that came out, and the performance is just phenomenal. But if you look at the pricing of ChatGPT, it's 1 penny per 1,000 tokens. This is an old sales trick. What you do is you minimize the overall cost down to just minute numbers. I've got a penny. Dang, I've got tons of pennies in my pocket. I can afford this. But what happens when you scale your product and all of a sudden you're starting doing hundreds of thousands, millions, billions of tokens? That one penny is now going to cost you thousands, 10,000s, hundreds of thousands, maybe millions of dollars as you scale your application up. So if you look at the cost of running ChatGPT 4 in the corner there, and if you compare it against Llama and ChatGPT 3.5 and IBM's Granite, it is 42 times more expensive to run ChatGPT 4 than some of these other models, especially Granite, where you're looking at specialized models specific for your use case. So for example, if you're starting to build a model for coding, you want a model just for coding, right? So do you care about the amount of rain in the rainforest that is in ChatGPT 4? No, of course not. So why are you paying for that data? Get a model specific for your use case. And what we see in the model, where we see the trends that are happening, is similar to what we see in compute. Who are my baby boomers here? Do you remember the old mainframes? Cards, stack of cards, printed out, run it through the mainframe, and the mainframe was just absolutely huge, took up the whole entire room, and it had less compute power than we have in a pocket right here. So we're seeing the same thing that were happening in the AI space. The ChatGPTs, Copilot, and things like that, they are the mainframes of the world. Expensive to run, expensive to train, and now we're seeing the migration into more of the mini computers. So after the mainframes, we had mini computers like with the DEC VAX, which was more cost effective, more compact, much more easier to use. You didn't have these punch cards that you had to print out your code, and then you can see everything on a screen. After that, you have the workstations, the PCs, and then, of course, the iPhone. So this is the migration that we're seeing with LLMs. So really look out for your use case if you're doing healthcare, such as Goodrx. If you're doing other things such as program, get a model specific to your use case. So if you look right here, Granite versus some of these other models specific for coding, it outperforms all these other models, and most important, is more cost effective than going with a large ChatGPT-like model. The other thing that's really important that we'll get into as we get into governance is what is inside that model. What is the transparency? Does it have copyright material? Is it toxic material? So look, as we get into the other parts of this presentation, transparency is extremely important when you look at the different models. And this is just a glimpse. It's kind of similar to what GitHub have, all these different type of models out there that you can choose from. So depending on your use case, get the model which is specific to your use case. You'll get the most bang for the buck. And the nice thing about IBM is they disclose everything in terms of how the model is built, and then they clean up the data so you don't have any copyright material, any toxic material. It's all business, strictly business material inside the models. All right, so I'm not gonna get into specific areas of RAG, but all you guys know about, you gotta have the right data, then you parse it, you create the tokens, you chunk it, create the embeddings, you put the embeddings into the vector database, and then you have LangChain that communicates to the LLM. I'm going to talk a little bit about some of the challenges that we faced when we were doing RAG. So when you start doing RAG, it really depends on the data that you're running and the overall goal that you're trying to achieve with the model. Are you going to do summarization, question and answer, translation? Do you have time series like security? Are you using a model just for code or multimodal? So some of the challenges that we ran into when we start to parse the data, you have to be careful that you want to keep the overall syntax of the data that you're starting to parse. So specifically around code, if you chunk it or if you parse it differently, you might lose the overall syntax of the code. The other thing that we ran into when we started converting XML files to JSON, we had a 16 megabyte test file that we're testing as we were parsing it. That 16 megabyte file exploded up to 250 megabytes. So when you're converting your data to get it into your model, you have to really make sure that you eliminate a lot of the duplicate information, irrelevant information, because the parsing is going to affect the overall quality of the model, kind of garbage in, garbage out. So as we did some of our parsing, as you can see here, we took data from this Apple Watch, and the data came out in this area right here where it says type. And so as far as the type, you see the HK, quantity, type, identifier, heart rate variability, SDNN, and then the value in the start and end date. We didn't care about all that information and type. All we cared about is HRV, heart rate variability. So what we did is if we parsed the data, we cleaned up all this information and we took that 48 character string, reduced it down to 3, which reduced the number of tokens 16x and reduced the overall cost by that same amount. So parsing your data is extremely important. And then we get into the chunking, as that one gentleman talked about. You have to be careful when you start to chunk the data that you don't chunk it too small, or else you're going to eliminate the semantic relationship between the words. If you chunk it too large, you can have a lot of irrelevant information in terms of the summary. So it really depends on the type of data that you're dealing with and your overall goals that you want to do with the information. So if you want to do very specific responses, chunk it smaller. If you want to do large queries, if you're more in the medical or science area, chunk it a little bit larger. And then make sure you don't lose the context between the different chunks. So if you ever read medical journals, they go blah, 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 it's very long, and they continue that through multiple paragraphs. If you start chunking it and you eliminate the train of thought between the different paragraphs, you're going to lose the entire context. The one thing that we ran into with embeddings, again, it really depends on the data and what you're trying to do with the data. So if you have semantic analysis, name recognition, quality, question answer, text classification, or language translation, you need to choose the embedding tool to extract that data exactly how you want it. So if you look at the different type of tools out there to do the embeddings, we've got BERT, base on case, which is really good for Q&A, name entity, sentiment. Then you have BERT large on case, which is really good for complex text classification. Distill BERT for real-time applications, such as security, Roberta and Albert for smaller hardware and faster training. The challenge, though, if you start to use an AI tool to start to do your embeddings, look at the transparency. How has that AI system been trained to do the embeddings? If you go with the cheap embeddings that you see online, they may be just using Albert for your embeddings. And the data that you're going to get from the embeddings, the quality is not going to be that good. So really be careful about how that model has been trained to extract your embeddings. It makes a huge difference in terms of the quality of the output. And the last thing in terms of RAG, where should you use RAG and what are some of the best practices? If you have a lot of content out there And if you're looking for more current content, then you need to use RAG. Some of the other ways of training that we looked at in terms of fine tuning is if your data is, rather the model, if you have limited amount of data in there and if you're missing data, then you need to switch over to fine tuning. And then the other issue is if your information has what we'll call long tails. Are you guys familiar with the term long tails? Okay. So within Tesla, you heard Tesla cars running into emergency vehicles a lot. That is a long tail. Because as we drive cars around, we really don't run into emergency vehicles that often. So the FSD model was not trained on these long tails. That's why those Tesla cars were just, they didn't know what the flashing lights were. They just ran straight into it. So you have to train the models on these long tails. The other thing that you want to use fine training for adversarial in terms of people attacking your model. But I kind of want to use RAG and the combination of RAG and fine tuning because how people attack your model is constantly changing. So you need RAG to have more updated information, but they're coming in specifically at a point of attack, then you want to fine tune your model to protect that. And then if you're using for domain specific, what we're doing with our teams is we are converting Splunk code so people don't have to use the Splunk code in order to get the data out. So we're training models specifically on Splunk SPL code so people can just use NLP to get the data out of Splunk. And finally, if the data that you're working with is specific area, such as legal, scientific, or medical, you need to use fine training, and you can get better consistency with the model itself. So you guys are pretty familiar with the different fine tuning types. You have the supervised with labeled data, unsupervised with unlabeled data, where you introduce masking, reinforced learning, where you have the rewards and punishment, and then transfer learning, where you transfer one model data to another. So some of the issues that you have to watch out for when you're doing your fine training is you're overfitting the model with too much training. So you can have the models too specialized in the area that you just trained on. Or you can have what we call underfitting, where you didn't train it enough. You're not changing the weights of the model enough because you didn't have enough data to change the output of the model. What we call catastrophic forgetting. That's similar to how humans think. So if you remember in the beginning of the presentation, you might have forgotten what I talked about earlier. The models is the exact same thing. If you start training it and giving it more information, that model will start to forget what it's been trained on earlier. So you have to be careful of not to overtrain it. The other thing you have to watch out for is the type of hardware that you're training the model on. If you're running into out-of-memory errors, you're going to start to lose data. If you're using a computer that's not powerful enough, you're going to get quantization, where it's going to step down from like an 8-bit down to a 4-bit, and you're going to lose precision in your data. So be careful of the type of hardware that you're training your data on. And then finally, if you can have bias amplification, you can also have what we'll call data mismatch, depending on how the structure of the data that you're training the model with. If the structure is slightly different, you're going to start to confuse the model in terms of the training. So we're going to talk about taxonomy here shortly. So there's a different approach to doing RAG and fine tuning that I think you guys are going to really enjoy. Number one, this way, there's absolutely no charge for this tool. And you can run this tool on a Mac or your laptop with a Linux operating system. And what it is a hybrid approach to doing RAG and fine tuning that's much easier to use and is more cost effective. And what is this Instruct Lab? So basically what you do is you take seed data, which may be like 20 or 30 different examples, and you feed that into the model. And then from there, you have to make sure you have the taxonomy correctly. And we'll talk about, I'll show you some examples of what taxonomy is, which is a structure of the data. So when you start to train the model understands the structure of it and can properly be trained based on the information. And then once you have the C data and you have the taxonomy, what we're going to do is we're going to synthetically generate additional information based on that training, because you need quite a bit of information to train the weights or the models in order to make an impact. And then finally have a validation. So what I mean by synthetic generation, it's like if you don't have enough data, it's like trying to change the Chicago River green with 1 gallon of dye. Has anyone been to Chicago where they changed the river? One person has. I've never seen that, but I think it's crazy. So on St. Patrick's Day, Chicago changes the river to color green to celebrate that holiday. The whole point here is if you're trying to do fine tuning, if you just have a few examples and you feed it up to your model, you may not change the weight at all, so you're wasting a lot of time. So we're going to use what we'll call synthetic data to change those models. So how we're going to do that is through, part of it is taxonomy. So what is taxonomy? So taxonomy, think of it as 2 different ways. First of all, is the structure of your data. So a lot of people on your laptop, you have a folder for My Documents, then you have maybe marketing, customers, downloads, things like that. So you have subfolders within the My Document. And then within those subfolders under customers, you might have a list of all your different customers with their names on it. Unlike how my wife has her PC, which if you look at her desktop, she has icons everywhere. It's just absolutely a mess. I go, why don't you just file everything into different folders so you can find it? Don't worry about it. I can find this information. But if you do that to a model, if you have a messy desktop, it's the same thing. The model is not going to find the information. It doesn't understand the taxonomy if it's all jumbled together. After that, you need to have the proper knowledge, which is feeding the information to the model. Have you guys seen the movie Matrix? Where you just plug in that thing in the back of your head and then you can do anything that you want. You can learn karate, you can fly a plane. That's the same one thing is you got to provide knowledge to the model as you train it. And then secondly, you have to give it what we call foundation skills. Foundation skills are things like math, coding, and reasoning. And then finally, putting it all together is combining both the knowledge and the foundational skills to do something such as write a report. So let's take a look at an example of what I'm talking about. So remember when I talk about the structure of the data, the taxonomy. So if you look right here, you have the different folder types, which you have the knowledge, foundation skills, compositional skills. From there, you have to give it the information. So for example, we are a hedge fund, or if you want to be a quant, and you want to make recommendations to customers in terms of what stocks to buy. If you bought Tesla yesterday, it went up 30 points today. You made a bunch of money. So if you look at this model right here, if you're a quant, if you're a broker, so you want to give knowledge in terms of financial information, profit, loss, things like that. And then skills such as math, so they can do the quick ratios, PE ratios, things like that. And then finally, you give it compositional skills where you combine all that information together so they can write a report on terms of what stock to buy. And then you give an example. So I think An easier example to think about is knock-knock jokes. So if you want the model to create thousands of knock-knock jokes, so you give it knowledge, you always have a structure of knock-knock, right? The first thing you say, knock-knock. Who's there? Banana, banana repo, banana, banana. Banana who? Banana, banana. I can't remember all these knock-knock jokes. So I had to use this model to help me learn some new knock-knock jokes so I can tell my friends. So I would give that example into the Instruct Lab and give it some examples of knock-knock jokes. I give it the knowledge, foundation, compositional training, and then the model creates hundreds, thousands, depending on how big your hardware is, any type of knock-knock joke that you want. And then once you get that knock-knock joke, you want to validate those jokes to make sure they're good. And then you feed those jokes into your model, and then you're good to go. So this is what it will look like. So as I mentioned before, I talk about the category, the subcategory, the task, the seed information, the knock-knock joke, and then the model itself will create all these different examples for you so you can fine-tune the model automatically. You don't have to sit there and do all that. The model will do it for you. All right, so now that you've chosen your LLM, you've done your tuning, what you want to do is similar to what Dave was talking about, is you want to prompt that model to make sure it's doing what you've trained it to do. So we have very similar capabilities of what David talked about. You can create all these different prompts, and then you can change the model or LLM to test it and see which LLM is best to get the best answer for you based on those prompts. You can change the number of tokens. So if your goal is to have a short question and a short answer, you can test them all by changing the number of tokens as you do the prompting. There's also pre-built prompts into the tool, so you can generate text for additional information, such as blog posts or stories or marketing information. And then you can do experimental information. And finally, it ties into Jupyter Notebooks, and it will store all your different prompts so you can save those prompts in case the person who's built and trained that model, you have a repository of all those different prompts, and you can test it again. So you can also test for drift if the model is not quite right based on the same number of prompts. This is kind of what it looks like. So if you see right here, you have definition of the model, the number, the prompt itself, and then the answers. And you can run this. You can see in the very corner there, you can just hit run, and then you can run this prompt multiple times, test it out, test it on different LLMs, and then save that prompt to see if your model has drifted. You can change the weights of the model over here, the weight parameters, the temperature, the top P, and then the tokens, etc. And finally, it creates the code for you. And you're thinking, why do I need code for prompting? And that brings us to the future of where LLMs and agents are going. Have you guys heard of agent tech? A few of you guys? So this is the future of where a lot of the analysts think AI is going. So think of agent tech as a company. So within the company, let's pretend we are a game company and we want to create new games. So you have to have a person doing the design work. You need a person doing the coding. You need a person to do the testing. And then finally, you need a person to do the documentation. So rather than having people at each one of these workflows, we're going to put an agent or an LLM to do that work for us. And then we're going to use networking and orchestration to choose to do the workflow between these different LLMs. So what would that look like? So let's get back to the coder. So the design team has created a design, which was an LLM agent. That LLM agent, through orchestration, would send that information over to the coder. That coder is not a person. That coder is an LLM specific for coding. And that could be that IBM Granite specific for coding. Based on those requirements that they got from the design team, that LLM coding would actually start coding that game. And then after the coder, the LLM has finished the coding, through orchestration again, it would send that code over to a tester or a developer to check on that code. So this LLM would actually run the code, test it out, and then find some errors in that code. And then when that LLM finds those errors in the code, it would send it back to the coder, and the coder would fix those errors and then send it back to the tester to say, hey, I fixed the code, check it again. This LLM would check the code, say everything is perfect, and then send it back to the coder, and the coder then send it to production, and then you're ready to go. So why would someone implement agent tech? If you look at zero shot with the GPT 3.5, you get about a 48% response accuracy. Compare that to GPT-4, which is 67%. And remember I talked about the price of ChatGPT-4, which is 42 times more expensive than ChatGPT 3.5. But now look at this. If you use agent tech and combine all these agents together, you would change ChatGPT from 48% to well above a single shot of ChatGPT 4. So think about that. You get extremely better accuracy at a much lower cost by using agent tech. And this is the future of going with instead of a huge mainframe model, you go with more specialized models specific for each use case. You network them together and use orchestration to do the agent tech. All right, so now that you've chosen the model, you've done all the tuning, you did the prompting, and now you launched it out there. But you're not done yet. You have to do governance to make sure the model isn't jailbroken, it doesn't hallucinate, doesn't toxic materials, and then you have to have security. And then you want to automatically look for compliance against these new rules that are coming out against AI. And then you want to have a content store. Is my model actually really good? You want something to grade your model to see if it is accurate in providing the content to your customers. You want to be transparent, accountable, ethical, and then you want to have continuous monitoring of that model. So think of governance as JIRA, quality assurance, regulations, a knowledge base, and Splunk all combined into one. So this would be an example of checking your model for quality. So think about this as similar to your professor grading your paper. So within this test result, it looked at readability, rogue, meter, things like that. So it looks at how easy was this response to read. In this case, we didn't tune it that well, and we had a score of 52. So we need to go back and tune the model to provide better content to our customers. But the other metrics are actually okay, so we're good there. So we just have to tune it in terms of the quality of the output. And this is a way of actually looking for drift automatically. So rather than doing the prompting and you store it in Jupyter notebooks, you can have this tool monitor your model for drift automatically. And then finally, what we're working on, since we are a Splunk partner, you need to monitor this AI system 24/7. So we are integrating the governance into Splunk, so you have a single pane of glass, not only for AI security, hallucination, toxicity events, but you're combining that with the IT operations traditional security events. So you have a single pane of glass for all of your AI and traditional security events. There's quite a bit of other tools that IBM has. I won't go into everything. But the good news is with all the IBM tools, they're IBM branded, they're open source, and they're free for you to use. So let's get back to Bob. Bob fine-tuned his LLMs for IT operations and business. So he has what we'll call code-free analytics. He used RAG for security because he needs the data to be updated frequently. He recommended agent tech for future planning. And the results are the marketing team and the executives were extremely happy because they no longer needed to rely on IT in order to get the data out. They could just prompt the model and just get the model, the information that they're looking for through NLP. He used RAG for security, which helped him improve the overall availability of the website. And then finally, he eliminated the headcount because for security, if you look into security teams, they have to look at the monitor and they're getting thousands and thousands of events into the browser they have to attack. So rather than having people look at those security events, they're having an AI system look at it immediately, categorize it, and then helping the teams improve their overall productivity. So this presentation was more of a high-level life cycle, and then we can drill down later on into the technical aspects if you want. Any questions?
Anybody?
Thank you for the very interesting presentation. I wanted to ask a follow-up about the concept of using multiple models that are cheaper instead of one more expensive model. How did you go about evaluating the effectiveness of it, and how generalizable is this concept? Had you found success with this technique in a variety of different situations?
The first thing is look at the transparency of the model, which is super important. How was the model trained? What type of information is in there? And that's the challenge now, because a lot of models, they spin it up there, but you really don't know. It's like a black box. You don't know what's inside of it. So the industry is really pushing to see how that model's been trained. So if you look at that chart that I have earlier, where it had all the different LLMs. The nice thing about IBM is they're very transparent with how the model's been trained, what's inside of it. So you can start to pick and choose the models for your specific use case, and they have pricing available with that. But that's not available everywhere. So it's a little bit of challenge out there until the industry changes the transparency of the models. So good question.
Hello, hello. Okay. So just a quick question on cost of fine tuning. And then also, since I'm working on an AI project at the moment, I'm using some services to host my AI, like just to host like a public LLM. So I'm just wondering if anyone has ever had any experience fine tuning, how much that costed, and then also where are you hosting it?
The question about fine tuning. So that's where I recommend the Instruct Lab for fine tuning. That way you can have the computer do the fine tuning for you rather than you doing the masking and things like that. That takes a lot of work to fine tune the model. So I would experiment with the Instruct Lab. It's free available for you to download. You can run it on a Mac. But if you once you go into production though, I would highly recommend that you don't use the Mac because you get into the process. Remember I mentioned you can go from an 8-bit down to a 4-bit depending on the size of your computer. So if you're doing fine tuning on a Mac, you're down into the lower bits and the model's not going to be that fine. So run it on a more bigger processing machine, but start the fine tuning on the Mac because it's cheap and inexpensive and easy to use. But once you're ready to run it in production, use a bigger machine to start the fine tuning. Does that help answer your question?
A little bit. I'm just wondering, I've just heard from a friend that it's like it can cost up to thousands of dollars to fine tune some of these models. So I'm just wondering, I'm sure it's different from different model sizes. So with Instruct Labs, it sounds like you download it on your own computer. But if you want to fine tune in production and get a language model that's ready for production, you should probably take it to the cloud. So I'm wondering if you have any experience or if you know anything about how much the cost would be on the cloud.
I think it really depends on your use case and the type of fine tuning that you're trying to do. So yeah, email me and I can probably get you some technical resources to help you out. Unfortunately, my technical guy got the flu, so he's not here today. So.
Okay. We're going to take one last question, and then I believe Jeff is also going to be around after after the talk, so I can ask questions there too.
Thank you. Hello. Thank you for the presentation. That was awesome. One of the questions I had was you mentioned the networking and orchestrations of multi-agents. Is there a current practice or I guess paradigm that the industry is moving towards when they do this? Or I guess like, is there a name if I wanted to, because I've heard like system modeling language is something that I think people are working towards kind of diagramming and working through this type of networking and orchestration. I was just wondering if you could talk more about that.
Yeah, go to YouTube, look up Andrew NG.
Okay. He's already favorited on my computer.
Yeah, he's very good and talks about agent tech. The couple areas that I talk about agent tech, which you can do on your own, is reflection. It's kind of prompt engineering or just prompting. So reflection is you give the model a prompt, but then you get an answer back from the model. And then you want the model to reflect on that prompt. So you say, I want you to re-look at the prompt that you gave me and make it better. And what we do, we manually do agent tech. If you're a startup and you don't have a lot of money, so what you do is you open up multiple different LLMs, Copilot, Perplexity, Gemini. You get an answer from one model. You take that one answer and then you give it to another model. That's called reflection. And you tell the other model to look at this code, and I want you to make it better, and then say, please don't make up information. And you keep on going to the different models, and you keep on doing reflection. So you'll get better and better code as you go along. So that's a cheap way of doing agent tech, a manual way. Just open up multiple models and then keep doing reflection along the way.
Thank you. Thanks, Jeff. That was great. And then again, we're going to have this space until like 8 o'clock, so can mix and mingle and ask questions to the speakers and so on. Oh, by the way, before the file out, they actually have a very interesting project for the guys.
Yeah, if you can stop sharing there for Jeff, and then I'll share again here. So I talked a little bit about GitHub models, right? You can get a fair amount of information about different models there by going to github.com/marketplace and looking at models and that. but there's also a Copilot extension specifically for GitHub models. And to me, at first, that sounded a little weird, but the point of that is, okay, I'm working in VS Code, or I'm working in Copilot chat in github.com, and I can use Copilot to ask about, what model should I use for this purpose? What model, should I use for that purpose and such? And so I just wanted to kind of bring that up quickly. All right, so when you go to the marketplace, we've got a couple of different things here, right? Let me see if I can do this one-handed. Yeah, you've got Copilot, and you've got Copilot, and you've got models there in the marketplace. And if I go, like we were talking with models, right? You can get even just a lot of information. I can go in and it kind of depends on what the transparency of each model. What type of information do they actually provide here? How much detail and everything do they provide? But then also, if you're using Copilot, going back to the top level here, and there we go. Go into the Copilot extensions. There is a models Copilot extension. And what we see here is allows users to interact. Allow users to interact with LLMs listed on the marketplace through Copilot. List LLMs currently supported, ask for a recommendation on LLMs based on constraints, run inferences in particular models and things like this. So, we can use this to get model recommendations, provide feedback, drop in use of desired model and things like that. So, to be honest, my role is a developer advocate. I am not a deep in the weeds AI developer in that. So I don't know how useful you think something like this might be, but I'm just throwing it out there as something to perhaps check out.
Thank you, David. Yeah, I think there's a lot of information. So